In July 2025, skywatchers detected 3I/Atlas, marking only the third interstellar visitor plunging into our solar system at breakneck velocity. Yet once the James Webb Space Telescope captured a rhythmic, persistent radiance emanating from its heart, a luminescence no ordinary asteroid ought to produce, perspectives shifted dramatically. The entity's luminosity surged to triple the anticipated levels, devoid of any cometary trail or irregularity. Its spin maintained impeccable regularity. Then the revelation hit. Various research groups verified a thermal rhythm throbbing periodically, along with bursts of enigmatic radio emissions defying all recognized natural phenomena. Should this hold true, it might represent the inaugural sign of a constructed entity, not a cosmic byproduct, barreling our way at present. So what exactly is 3I/Atlas? And why is its approach prompting the planet's leading experts to insist on explanations? On August 6, 2025, amid the influx of observations from the James Webb Space Telescope, a team of near-infrared spectroscopy specialists noticed an irregularity that defied logic. Initial thermal images of the object revealed a focused emission right at its center. Far from a dispersed fog or broad envelope, it was a compact, pinpoint brilliance overpowering nearby particulate matter. The data arrived pristine, free from equipment glitches or interference from solar eruptions. Within the unprocessed graphs, the thermal profile was striking, an intensely luminous nucleus tapering into spectral gradients, all aligned on an unresolved central body beyond telescopic clarity. Under the guidance of Chief Instrumentation Expert Dr. Lena Marovich, the Webb crew reviewed alignment records and recalculated the figures. The output remained constant, registering 3 times the forecasted intensity for something of its dimensions and remoteness. Absent were any appendages, variations, or oscillations, just a resolute, constant signal. Their private discussion channel buzzed with inquiries. Could this stem from vapor release, or was it something more profound? Historical record reviews kicked off without delay. Observations from Hubble and ground-based arrays earlier that season suggested an energized form already shining well past Jupiter's path, ages before solar proximity would ignite typical cometary behavior. However, none of that archival material echoed the sharpness or vigor of Webb's fresh visuals. To the technicians, this screamed non-standard find. The warmth originated from profound depths, bypassing superficial solar exposure, and the force driving it operated outside conventional norms. Optical monitoring squads, directed by the Atlas Consortium in Chile and Hubble evaluators, initiated their independent verifications. Their primary worry centered on luminosity. Across all conventional gauges, 3I/Atlas gleamed at almost thrice the projected brilliance for an entity of its approximate scale and separation. Photometric analyses spanning days displayed a uniform, unflinching emission. Zero declines, spikes, or traces of the intermittence typically linked to gaseous ejections or irregular topography. In contrast, ordinary comets wax and wane with their rotations, their frozen exteriors sublimating unpredictably. This one's profile stayed nearly level, tied to a detected spin cycle of roughly 6 hours, ample to expose significant external dynamics, yet none surfaced. Hubble's detailed snapshots hunted for the hallmark streamer, the elongated vapor wake denoting cometary sublimation. Rather, the body encased itself in a compact, droplet-like sheath, resembling a veil over a tail. Experts observed that even at 6 astronomical units from the Sun, where illumination is faint and most wanderers slumber, 3I/Atlas exhibited vitality, illuminating the void. No conventional solar warming or gas expulsion framework accounted for the potency or the onset. Such inconsistencies baffled the visual analysts, an entity overly radiant, excessively stable, and unduly compact to align with established classifications. Standard cometary principles fell short. For the investigators, the path forward was evident. If the radiance didn't arise from the exterior, the key might reside further within. Webb's infrared specialists started parsing the sequential datasets, probing for rhythmic elements in the thermal flux from 3I/Atlas's nucleus. What seized their focus wasn't merely the strength, but its cadence. Approximately every 4 hours, the inner brilliance expanded and contracted in a measured, intentional sequence. The oscillation was undeniable, consistent, nearly machine-like, with power cresting centrally and propagating in undulations. No erratic twinkling, no disordered eruptions. The records overflowed with time notations, each capturing an ascent and descent that recurred with eerie accuracy. Dr. Lena Marovich and her colleagues correlated the timings with the object's spin and trajectory details, hunting for organic explanations. No correlations emerged. The warmth ignored external traits or stellar influence. It throbbed from internal recesses, indifferent to shifting solar angles or orbital spacing. To the Webb staff, it evoked less a comet's venting and more the pulse of deliberate design. Ground-based radio facilities spanning from California to South Africa redirected their dishes toward 3I/Atlas, scanning for electromagnetic signatures outside visible and thermal bands. The Allen Telescope Array, headed by Dr. Kavita Ralph, commenced combing after poring over extensive wideband recordings. The researchers sifted away ambient static and orbital satellite interference, pinpointing an outlier amid the noise. They detected a subtle narrowband signal pulsing at regular 4-hour intervals, its cadence unflinching. Fourier transforms validated the regularity. This consistent waveform sliced through the interference with a periodicity far too exact for mere interstellar static. Across multiple evenings, the emission remained consistent, though its schedule subtly adjusted in sync with solar wind variations, aligning precisely with readings from space weather observatories. Separate groups at Meerkat and Ethelberg corroborated the detection, eliminating nearby disruptions and Earth-based origins. The signal's endurance, its nuanced responses to environmental factors, and its duplication across hemispheres thrust a compelling inquiry to the forefront. Could this stem from a natural phenomenon or an intentional broadcast from an entity attuned to its environment? In mid-August 2025, the mystery intensified. The Webb telescope's real-time stream captured an abrupt burst. 3/2/Atlas surged in brightness by almost 40% within under an hour. The monitoring probe in Earth orbit verified the intensification. Observatories focused on the body all noted the identical uptick, extending beyond visible wavelengths to include heightened thermal emissions. For a fleeting period, the entity glowed as though an internal mechanism had activated. Moments later, the readings leveled off, settling at a higher steady state. Focus turned to its path. Marco Macelli and the ESA's near-Earth object specialists executed fresh simulations. Trajectories derived from prior months of observations now diverged from actual motion. Rather than floating aimlessly, 3/2/Atlas altered its route, curving nearer to the ecliptic plane. Macelli's analysts weighed possibilities: vapor release, observational inaccuracies, or an unfamiliar dynamic. The speed-up defied conventional comet patterns. For the first time, observations suggested directed adjustment, with the outburst and directional shift timestamped together in records. The dilemma grew more urgent. What sort of body redirects itself en route? And why in this remote ecliptic fringe? On August 18, 2025, the Webb's near-infrared spectrometer passed data to spectral experts. Carrie Liss's team at Johns Hopkins spearheaded the effort, examining unprocessed spectra from 3/2/Atlas. Standard cometary indicators, water vapor, frozen volatiles, carbon dioxide, appeared as expected, yet overlying them lay an enigma. Multiple absorption signatures failed to align with established databases. The surface reflectance suggested metallic compositions, including rare earth metals typically linked to sophisticated terrestrial fabrication. Embedded within the dataset were traces resembling hypothetical quantum constructs, concepts outlined in theoretical physics but unseen in the wild. To the analysts, these clues veered from haphazard stellar processes toward indications of deliberate design, at least in theoretical terms. By late August, restrictions on unfiltered observatory streams grew stricter. NASA and ESA internal directives invoked fresh handling guidelines under planetary defense pretexts. The SEI task force, overseen by an unidentified lead, grappled with the idea of beaming a numeric greeting toward 3/2/Atlas. Following a fraught decision, they dispatched it, sequences of primes, the elements table, and fundamental constants. Precisely 72 hours afterward, a narrowband response emerged. Accurate to the second. Though warped, the echo synchronized with the scent interval. Officials sealed the information, diverting exchanges to secure networks. Public conjecture exploded, while internally, the mood evolved from intrigue to guarded restraint. During the August IU Symposium, for primary hypotheses, expulsion vents, nuclear warmth, particle diffusion, and bulk miscalculations, underwent scrutiny and fell short. None accounted for the sequence of irregularities. With the September close pass looming, preparations accelerate. All sensors stand ready, awaiting revelations that might resolve the enigma. On August 6, 2020, the James Webb Space Telescope captured 3.2/Atlas, releasing infrared radiation 3 times more intense than theoretical estimates for its dimensions. In the ensuing weeks, specialists noted a focused intermittent thermal emission, a recurrent radio emission, and an abrupt 40% luminosity spike that aligned with a path deviation. These details were validated by TESS, Hubble, and European Space Agency satellite observations. Spectral breakdowns uncovered rare Earth metal compounds and absorption features absent from existing inventories. Even after numerous external evaluations, conventional accounts like venting, nuclear breakdown, and particulate haze were dismissed by the International Astronomical Union Review Board. As of late September 2025, the nearest encounter draws near, with premier facilities gearing up for in-depth examination. One thing stands certain. 3.2/Atlas upends prevailing theories on extrasolar visitors, and its impending Earth transit marks a pivotal juncture in astronomical inquiry.